Yeah, I can.
Yeah, hi everyone. Good evening. Today we are going to present the presentation on measuring the algorithm efficiency of the neural networks. As we know, the neural networks is the most enlarging technology nowadays. It is depend on the how human mind deals with the software systems. And here is the list of the team members, and we will provide the presentation video link afterwards. Go to next slide. Today we are going to discuss about what is the neural networks and the metrics and measuring of the algorithms and the memory usage and model size, interface times, strengths and limitations, advantages and disadvantages of the neural networks. Finally, we will give you a conclusion on the neural networks, how neural networks will be used in the further coming days. And we can also provide the references for the content we have searched. Go to next slide. Yeah, coming to the introduction, thus in this presentation, we will discuss the major concepts of the efficiency measuring techniques for the neural network algorithms. So we know that the neural networks are the most recent popular technology that able to task try to solve the major problems in the human world. So we can use this type of neural networks for the increase in the size and the complexity of the neural networks, because it's very challenging and the measure of the algorithm is very difficult nowadays. So the main object of this presentation is to provide a clear observation of the how neural networks will be used in the coming days. Go to next slide. Murli, you can proceed.
Hi team, I'm Morley. Today I'm going to explain about the significance of algorithm efficiency in neural network. So as we know, now neural networks are a backbone for modern AI applications, driving advancements in our computer visions and natural language processing for everything and more. The efficiency of these networks directly influences the practically and viability to the real world applications and scenarios. So today we are going to discuss about the impact on computational resources. So as we know, efficient algorithms optimize the resource of utilization and enabling the neural networks to run on a variety of hardware from the edge device to cloud servers. And then efficiency utilization on computational resources contribute to cost cutting edges and the cost effectiveness, scalability, efficiency, essential in large scale employments and deployments. So speed and real world. So now we are going to discuss about speed and real world applications. Algorithm efficiency is pivotal for achieving faster interface times to play a crucial life in real time applications like automobile vehicles, video processing and live streaming, etc. So improved speed enhances user experience, a widens the scope of application and making the neural network is more reliable to the real world applications in diverse domains. So we are going to discuss about a balancing act. We're talking about the performance of those essential strike balance between the accuracy and the computational efficiency is very crucial to modern era. The demand of these faster and more efficient neural network systems form an increasing need of AI technologies to seamlessly integrate to everyday life. And so here comes the matrices of measuring an algorithm efficiency. Floating point operations per second flops is a measure of number of floating point operations a neural network performs per second. It measures the computational complexity of neural network. And we're talking about the memory usage. Memory usage measures the amount of memory of a neural network to require the store and its parameters and the intermediate computations. And memory usage is an important metric determines for scalability and the neural network. And we're going to discuss about model size and interface time. When it comes to model size, it's measured the number of parameters of the neural network and has a capability of smaller number of parameters is more efficient than the network with the large number of parameters. And it's a positive thing. Positive side is requires only less memory of computational resource to train and use the model. And we're going to talk about interface time. Interface time measures time taken by the neural network to generate the predictions that make decisions after being trained. And it's a crucial metric for the real-time applications such as autonomous vehicles, where decisions need to be made in milliseconds. So we're going to go through into flops that can be used to compare the speed of different neural network. For example, we're talking about neural network A has flops of 100 million and the neural network B has flops of 50 million, the network A is faster than network B. Then we measuring the flops, we can determine computational resources required to train a run on a neural network, which is more optimized performance than other one. So we are going to discuss about memory usage. So I will hand over to Priyanka. Priyanka will take care of that.
Hi, I'm Priyanka. I'm going to discuss about the memory usage. Memory usage refers to amount of memory of neural network requires to store its a parameter and intermediate computational. It is an important metrics to measure it determines scalability of a neural network. And then the large of the memory usage of neural network, the more resources it requires to run, and the more difficult it becomes to run on a large data sets. And then memory usage can be used to compare the scalability of different neural networks. For example, if a neural network A requires 2 GB of memory to store its parameters and intermediate computational, while network B is required 4 GB, then network A is more scalable than network B. And next slide. Is related to model size. Model size refers to the number of parameters in a neural network. It is an important metric because it determines the computational resources request to train a number of the network. The large model size, the more computational resources are required to train a network and run in a durable interfaces. And then it's like model size can be used to compare the computational resources. A request to train and run different neural networks. For example, it's a neural network A has a 10 million parameters, while network B has 100 million parameters. Then network A is more efficient than network B. By measuring model size, we can optimize the size complexities of a neural network for various applications, which is crucial for efficient and effective performance. The next slide, my friend Ishwar will continue. Ishwar, can you unmute your mic?
Yeah, consideration for measuring algorithm efficiency. While measuring the algorithmic efficiency of neural networks, it is important to consider the specific application and available resources. The choice of metrics used should depend on the specific needs and constraints of the application. In other ways, additionally, the relevance of each metric may depend on the specific architecture and implementation of the neural network. For example, a neural network with a large number of parameters, it has a high model size, but still require relatively low computational resources because the efficiency implementation of the network. Next slide. Next slide. Here, future directions. There are two innovations like hardware innovation and the novel architecture. Coming to the hardware innovations, there are three. There are like two types, like quantum computing and specialized hardware. Coming to the quantum computing, explore the potential impacts of quantum on neural networks computation. It has algorithms may revolutionary of training and interference process. Specialized hardware. Investigate development in specialized hardware. Efficiency, accuracy, dynamic network architecture explores adaptive architecture that dynamically adjusts their complexity based on input data, allowing for a balanced chips designed to accelerate specific type of neural network operations. Novel architecture like spiral neural networks and capsule network. Coming to spiral neural networks, delving into the possibilities offered by spiral neural networks where only a subset of connections is to be activated, reducing computational requirements while maintaining performance. And the capsule networks comes like discussing going research on capsule networks, which aims to address inefficiency in traditional neural networks. Architecture by capturing hierarchical relationships more effectively. One next slide will continue by Sabrina.
Yeah, hi, this is Sabrinath. Yeah, we're going to speak efficiency accuracy trade-offs. Dynamic network architecture explore aggregative architectures that dynamically adjust their complexity based on their input data and allowing for a balance between efficiency and accuracy in varying contexts. Yeah, AutoML and neural architecture edge. Discussing the role of the automated machine learning and neural network architecture cell algorithm in discovering more efficient network configuration. Quantifying efficiency. Proposing the development of standardized metrics that comprehensively measure algorithms' efficiency, accounting for factors like energy consumption, model accuracy, and inference speed. Yeah, efficiency benchmarks advocate for the creation of widely accepted benchmarks to access the efficiency of neural networks across diverse tasks and datasets. Yeah, next slide. At last, we conclude that measuring the algorithm's efficiency of neural networks is essential for optimizing their performance, allocating computational resources effectively and efficiently, and comparing different architectures and implementations. Flops, memory usage, model size, and inference times are commonly used metrics for measuring algorithms efficiency, but the choice of metrics should be depend on the specific applications and application researches. While measuring algorithm efficiency has its strength, it is important to recognize its limitations and consider other important factors such as accuracy, interpretability, and robustness. Overall, measuring algorithm efficiency is an important part of developing effective and efficient neural network solutions. Yeah, thank you.
Thank you,
So
everyone.
team, we explained the explained everything about the measuring of algorithm of efficiency of neural network, and we're checking all the detailed things about neural networks. I think that's fine. We can go with this and wind up the video. Thank you.